Hello children, I am Shubhajit. In the previous session, we have learnt about how the periodic table was created. Today, we will learn about some of its salient features and its application. Before starting a new session, let us revise previous ones. Dubonnet grouped the elements based on their relative atomic masses into groups of 3 triads. John Newlands arranged 56 known elements in the increasing order of their atomic mass. Dmitry Mendeleev proposed the law of periodicity. Mendeleev's periodic table has 8 vertical columns called groups and 7 horizontal rows called periods. In the modern periodic table, all the elements are arranged in the increasing order of their atomic number. There are 7 periods and 18 groups in the modern periodic table. The elements are placed in periods based on the numbers of shells in their atoms. Based on the common characteristics of elements in each group, they are grouped as various families. Learning outcomes. At the end of this session, you will be able to understand about classification of elements into blocks, advantages of the modern periodic table, position of hydrogen in the periodic table, position of rare gases, periodic properties of the elements in the modern table. Keywords: block, alkali metal, halogen, rare gas, atomic radius, ionization energy, Before starting the session, let us look at this concept map. We know that the electrons in an atom are accommodated in shells around the nucleus. Each cell consists of one or more subshells in which the electrons are distributed in certain manner. These subshells are designated as S, P, D and F. Based on the arrangement of electrons in subshells, the elements of periodic table are classified into 4 blocks, namely S, P, D and F blocks. Number 1. S block elements. It includes group 1 alkali metals and group 2 alkaline earth metals elements. They are also called as representative elements. All the elements of group 1 except for hydrogen are metals. They react with water to form solution that change the color of a litmus paper from red to blue. These solutions are said to be highly alkaline or basic in nature. Hence, they are called alkali metals. The elements of group 2 are also metals. They combine with oxygen to form oxides, formerly called earths. And these oxides produce alkaline solutions when they are dissolved in water. Hence, these elements are called alkaline earth metals. 2. P block elements. These elements are in group 13 to 18 in the periodic table. They include boron, carbon, nitrogen, oxygen, fluorine families in addition to noble gases, except for helium. They are also called as representative elements. The P block is home to the biggest variety of elements and is the only block that contains all three types of elements: metals, non-metals and metalloids. Number 3. D block elements. It includes group 3 to group 12 elements of the periodic table. They are found in the center of the periodic table. Their properties are intermediate to that of S block and P block elements, and so they are called transition elements. Number 4. F block elements. It includes 14 elements after lanthanum, La57, called lanthanoids, and 14 elements after actinium, Ac89, called actinoids. They are placed at the bottom of the periodic table. They are also called as inner transition elements. The table is based on a more fundamental property, that is atomic number. It correlates the position of the element with its electronic configuration more clearly. The completion of each period is more logical. In a period, as the atomic number increases, the energy shells are gradually filled up with until an inert gas configuration is reached. It is easy to remember and reproduce. Each group is an independent group and the idea of subgroups has been discharged. One position for all isotopes of an element is justified, since the isotopes have the same atomic number. The position of the 8th group in Mendeleev's table is also justified in this table. All transition elements have been brought in the middle as the properties of the transition elements are intermediate between the left portion and the right portion elements of the periodic table. The table completely separates metals from non-metals. The non-metals are present in the upper right corners of the periodic table. Hydrogen is the lightest, smallest and first element of the periodic table. Its electronic configuration 1:1 is the simplest of all the elements. It occupies a unique position in the periodic table. It behaves like alkali metals as well as halogen in its properties. In the periodic table, it is placed at the top of the alkali metals. Number 1. Hydrogen can lose its only one electron to form a hydrogen ion H+, like alkali metals. Number 2. It can also gain one electron to form the hydrogen ion H-, like halogens. Number 3. Alkali metals are solids while hydrogen is a gas. Hence, the position of hydrogen in the modern periodic table is still under debate as the properties of hydrogen are unique. The elements helium, neon, argon, krypton, xenon and radon of group 18 in the periodic table are called as noble gases or rare gases. They are monoatomic gases and do not react with other substances easily. Due to completely filled subcells, hence they are called as inert gases. They are found in very small quantities and hence they are called as rare gases. Atomic radius. Atomic radius of an element may be defined as the distance from the center of the nucleus of the atom to its outermost shell. Atomic radii increase from top to bottom in a group column of the periodic table. Atomic radii of an element decreases across a period from left to right. The energy required to remove an electron from the outermost orbit or shell of a neutral gaseous atom is called ionization energy. Ionization energy decreases as we go down in a group and generally increases from left to right in a period. Ionization energy is expressed in kilojoule mole inverse. What have you learnt? Anomalies in the arrangement of an element based on increasing atomic mass could be removed when the elements were arranged in order of increasing atomic number. A fundamental property of the elements as discovered by Moseley. Elements in the modern periodic table are arranged in 18 vertical columns called groups and 7 horizontal rows called periods. Elements thus arranged show periodicity of properties including atomic size and ionization energy.